So today we're going to be looking at solving systems using substitution. So we want to understand that sometimes solving systems graphically just doesn't make sense, and there are easier ways to do that in certain circumstances. And one of those ways is solving by substitution. So we're going to take a look at some examples. Right, sometimes graphing isn't the best way to solve a system. Graphing is good if the equations are in slope-intercept form. Right? Graphing is good if the point of intersection is nice. In other words, if that point of intersection is at whole numbers. Unfortunately, we don't always know that ahead of time. And it's also nice if the numbers aren't too large. I don't want to use this huge graph and have to deal with different scales on each axis. So those are times when graphing is okay to use. But if you take a look at a situation like this, remember, a solution to a system of equations is the point of intersection, right? Can you tell what this point of intersection is? Well, if I take a look at it, this looks like, well, it's about halfway. So there's 1, and there's 1.5, but it's not exactly at 1.5. And if I look at the y-axis, it's almost at 2, but not quite at 2. So it's just not a good system to solve graphically because I can't see that point of intersection really easily. It's not whole numbers, and I can't just guess at a solution. So another way to do this would be by using substitution. We already know a lot about substitution from the past, so this shouldn't be anything that's real new. So this is a good way to solve equations when one of the variables is by itself in one of the equations. So here I have x by itself, and so that makes it a good substitution system of equations. Let's get my pen going here. So let's see. Let's get back into full screen. So x is by itself. So I have x equals this value or this expression. So notice here's another x. Well, if x equals negative 2y minus 4, then I can just replace x with 2y minus 4. So that's our substitution. So let's take a look at how that looks in an example. All right. Well, I want you to write down these steps so you can refer back to them. So number 1, you want to get a variable by itself if necessary. Well, in this example we just looked at, x is already by itself on the left-hand side, so I don't have to do that step in this particular example. But again, still write it down. Step 1, get a variable by itself if you need to. Number 2, you want to substitute that expression into the other equation instead of that variable that's there. So now you have 2 times x. Well, again, if x is negative 2y minus 4, I'm just going to take that and replace x with negative 2y minus 4. So 2 times negative 2y minus 4 is what's going to become of this piece of the other equation. All right, so this is our new equation. Again, I just substituted in place of x. Step 3, I'm going to solve that new equation using distributive property and balancing. So let's look at this one piece at a time. So this is the same as what I had here just a minute ago in the last screen. I have 2 times, instead of x, negative 2y minus 4 plus y equals 1. So we know from here we need to use some distributive property. All right, so I've distributed that 2. 2 times negative 2y is negative 4y. 2 times negative 4 is negative 8, and I still have this plus y. I'm going to simplify that further by combining my like terms. It looks like I have negative 4y and positive 1y. So negative 4 and positive 1 is negative 3y. And then I have a plus negative 8. If you just have minus 8, that's all right as well. I'm going to keep going by balancing this out. So if I have a negative 8, I want to add 8 to both sides. So I'm going to end up with 9 on the right-hand side. So negative 3y equals 9. And we know from there we need to divide each side by negative 3. And I'm going to end up with y equals negative 3. So there's one value of my solution. Now I need 2 values. It's an intersection, right? It's an ordered pair. So I need an x and a y. All I have so far is a y. So the value that we just found is only part of our solution. It's part of our ordered pair. Again, we need to find that other value, that x value. All right, so here we go. Step 4, again, please write down the steps. You need to find the other part of the ordered pair. So we're going to go back to our original set of equations. Here was our original system. Now we took this, we substituted, right? So I'm going to look at that. I like using that equation that I used in the first place. But remember, either one will work. You don't have to use this one. You can use your other equation if you would like. So we just found that y equals -3. So now what we can do with that is take that and substitute it into one of the equations. Again, I'm going to use this one, but you could use this one if you would like. This one's going to be a little bit easier, again, because x is already alone. So let's take a look at what that looks like. And I'm just going to use some substitution. I'm going to say, right, x equals -2 times y. Well, we know that y is -3. So I'm going to substitute that -3 in place of y. So 2 times -3 minus 4. Now you're just going to calculate from here. -2 times -3 is +6. And finally, 6 minus 4 is 2. So now we have both values to the solution of our ordered pair. So step 5, again, please write your steps. Write down your solution as an ordered pair. So y was -3 and x was 2. Just be really careful that you write these down in the correct order, x, comma, y. Otherwise, if you flip them around, that makes it a whole different ordered pair that's not going to work necessarily in the system that we had, right? So there are your 5 steps, but now we're going to skip that one. Now we're going to take a look at an example. All right, so let's do our 5 steps. All right, 1, get a variable alone on one side. Done, right? Nothing I have to do there. I already have a variable alone. Okay, step 2, substitute that equation into the other equation. Try to ignore this over here. We're on step 2. Okay, so I'm going to substitute 4y minus 9 into x right here. So 2 times 4y minus 9. So that's what that step is going to look like. I just took the 4y minus 9 in place of x. Remember, this is multiplication. So we have to use some distributive property. So we're going to use that distributive property in balance. I'm going to encourage you to pause here for a second. Go ahead and use your distributive property to see what your equation is going to look like. All right, so my first step when I've used my distributive property is 8y minus 18, because 2 times 4 is 8. 2 times -9 is -18. I still have this plus 8y, right, equals -2. I'm going to go ahead and I'm going to keep simplifying. All right, well, I have 8y and 8y, which is 16y, minus 18 equals -2. All right, well, it looks like if I add 18 to both sides, -2 plus 18, I'm going to get 16. So 16y equals 16. Divide both sides by 16 and I get y equals 1. All right, so now I have my y value. Let's scroll up here a second. So step 4, substitute that into either equation. I'm going to pick the easiest one. I still want to find x. I have x alone here. So I'm just going to substitute that value that I just found into y right here. Pretty simple. I have x equals 4 times 1 minus 9, which means x equals 4 minus 9. And finally, x equals -5. So there's step 4. Step 5, pretty simple. We want to write that as an ordered pair. So I have -5, comma 1. Make sure that they're in the right order. X is -5, y is 1. All right, well, let's double check that up here to make sure that I have the right values. And -5, 1 is indeed my solution to this system of equations. I want to look at one more example though, because sometimes one of the variables is not alone on one side of the equation. In this system right here, let's see, grab that pen. All right, so in this system right here, notice x is not alone. It's got a 2, it's added to a 2y, right? So I still want to pick the easiest equation to work with. And to me, this one is going to be the easiest equation to work with first because x doesn't have a coefficient other than 1. If you have a variable with a coefficient of 1, that's going to be the easiest equation to work with, right? So jot down in your notes, coefficient of 1 is going to be the easiest equation to work with, right? So I'm going to pick that second equation. I'm going to follow my steps. Well, first, again, number 1 was get a variable alone. So I need to do something this time. I have x plus 2y equals 10. If I want to get x alone, I need to subtract 2y from either side to balance that. And I have x equals negative 2y plus 10. So now I have x alone on the left-hand side. Okay, so what was step 2? Think to yourself for a second or look at your notes. Step 2 is to substitute what I just found into the other equation. So I'm going to substitute this negative 2y plus 10 into wherever I see x in that other equation. So now I have, take a moment to write that down, write down your substitution. And that should look like this. 3, right here, times negative 2y plus 10 plus 4y equals 18. So you can see in the purple there, that's where I substituted negative 2y plus 10 in place of x. Okay, step 3. I'm going to simplify that by using my distributive property, combining some like terms, and then balancing that equation out. My distributive property should look like this. Negative 6y plus 30 plus another 4y equals 18. As you can see in red, I have some like terms that I need to combine. So I have negative 2y plus 30 equals 18. Now I want to encourage you from here, pause the video and look for your solution. So what does y equal? If I subtract 30 from both sides, negative 2y equals negative 12. Divide by negative 2, and I get y equals positive 6. So it looks like I have my y value. But I'm not done, right? I only have one of the values of my ordered pair. So step 4, substitute that into one of the equations. Again, either one, it doesn't matter, to find my other value. I'm going to choose the easiest one again. I'm going to choose the one that just has a 1 as a coefficient because that's going to make things a little bit easier. So I'm going to take that y equals 6. I'm going to substitute it into my x plus 2y in this second equation here. And I'm going to get now x plus 2 times 6, because y is 6, equals 10. Well, from here, I have x plus 12 equals 10. Subtract my 12 from both sides, and I end up with x equals negative 2. 10 minus 12 is negative 2. So now I have both of my values of my ordered pair. Again, in the right order, x is negative 2, x goes first, and then 6 is second. Well, I'm going to actually add a step to your notes. So I want you to write down step 6. Step 6, check, check, check. Check this ordered pair. Make sure it is a solution to both equations. Right? We've done this before. So if x is negative 2, I have 3 times negative 2, y is 6. So we're going to replace y with 6. So it looks like I have negative 6 here, 3 times negative 2, plus 4 times 6, which is 24. Now does negative 6 plus 24 equal 18? plug that into your calculator, or you think about that for a second mentally. Yes, that is true. Negative 6 plus 24 does indeed equal 18. All right, so I'm going to do that now with my second equation as well. So again, x is negative 2. Do this down below since that's where I have room. Y is 6. All right, so now it looks like negative 2 plus 2 times 6, which is 12. Does negative 2 plus 12 indeed equal 10? That does check out. 12 minus 2 is 10. Works in my second equation as well. So this is indeed a solution to this system.